So our first example, we're going to need to evaluate the function for the following values. Our function is f of x equals 2x minus 6. And then we have f of 3 equals, f of 1 equals, and f of negative 1 equals. Okay? Every time we see f of 3, that just means x is equal to 3 because our variable is x. Okay? Anytime we see f of 1, that means x is equal to 1. And every time we see f of negative 1, that means x is equal to negative 1. Alright? So, after this, we have f of 3 equals. We're going to use the function we were given, and we're going to plug in 3 for x. So f of 3 will equal 2 times 3 minus 6. 2 times 3 is 6. So 6 minus 6 is 0. So f of 3 is equal to 0. Now, the next example, x is 1. So we're going to plug in 2 times 1. So we have 2 times 1 minus 6. 2 times 1 is 2. Minus 6, so f of 1 will equal negative 4. For f of negative 1, this means x is equal to negative 1. So we're going to plug in a negative 1 for x. So f of negative 1 will equal 2 times negative 1 minus 6. This will equal negative 2 minus 6. So f of negative 1 will equal negative 8. So we're going to evaluate the following function for the specified values. Our function is g of b equals b squared minus 2b plus 1, where our first value is g of 3. It's the first value we're going to look for, where b is equal to 3. Second one is g of negative 2. It means b is equal to negative 2. For g of 3, we're going to plug in the 3 every time we see a b. Okay, every time we see a b, we're going to plug in 3. So g of 3 will equal 3 squared minus 2 times 3 plus 1. 3 squared is 9. 2 times 3 is 6, so it's 9 minus 6 plus 1. So g of 3 will equal 4. 9 minus 6 is 3, plus 1 is 4. Okay? Now for g of negative 2. b is equal to negative 2, so we're going to plug in negative 2 for b. So we will have negative 2 squared minus 2 times negative 2 plus 1. 2 squared is a negative 2 squared is a positive 4. Negative 2 times negative 2 is a positive 4 plus 1. So g of negative 2 is equal to 4 plus 4, which is 8, plus 1, which is 9. Now, for the next example, we're going to determine the range if the function has a domain of negative 2, 1, and 3. Our function is going to be d of t equals 2t squared minus 7. Now our domain is just our x values. This means x equals negative 2, x equals 1, and x equals 3. And for those, it's not x. In this case, it's t. In this case, we have t equals each one of these values, so we need to find the y value. That's what the range is. The range is the corresponding y value. So just like we did before, now that we have values for t, we're going to find the y value when t is negative 2 first. So we're going to do d of negative 2 equals 2 times negative 2 squared minus 7. So this says t is negative 2, so plug in negative 2 for t. Negative 2 squared is 4, times 2 is 8. So our first y value is negative 1. So d of negative 2 is equal to 1. Now for our next value, t is equal to 1, so we're going to find d of 1. So we're going to plug in 1 for t, so d of 1 will equal 2 times 1 squared minus 7. 1 squared is 1, times 2 is 2, so 2 minus 7. So d of 1 will equal negative 5. Our last domain value is 3, so we're going to find d of 3, which will equal, plug in 3 for t. So 2 times 3 squared minus 7. 3 squared is 9, times 2 is 18. So 18 minus 7 gives us 11. So d of 3 will equal 11. Now that we have our y values, we can write our range. So our range will be the set of values 1, negative 5, and 11.